Alright, so let's wrap up this section with a more complicated example. So we still have a second order differential equation, y double prime plus 2y prime plus 2y, and the right hand side is sine t. And the initial condition y of 0 is 0, but y prime of 0 is 1. So that's the same thing. We want to do Laplace transform, so let's first recall that the Laplace transform of y double prime is s squared times capital Y minus s times y is 0 minus y prime is 0. And the Laplace transform of y prime is s times uppercase y minus, no s here, just y of 0. And because of the first initial condition, these terms are not here, and y prime 0 is 1. Sorry, 1. So the left-hand side of the Laplace transform is going to be s squared times uppercase y minus 1 plus s times uppercase y times 2 plus 2 times uppercase y equals to, if you look at a chart, the Laplace transform for sine t is 1 over s squared plus 1. Okay. So let's move terms around. So y times s squared plus 2s plus 2 is equal to 1 over s squared plus 1. Don't forget this 1 here, plus 1. And this is equal to s squared plus 2 over s squared plus 1. So y, and this thing, if we complete the square, this is equal to s squared plus 2s plus 1, and then plus 1, which is equal to s plus 1 squared plus 1 squared. So y of s is equal to s squared plus 2 over s squared plus 1 times s plus 1 squared plus 1. Okay. So the method of partial fraction tells you that the original fraction can be split into two separate fractions. So the denominators are s squared plus 1 and s plus 1 squared plus 1. And here we have as plus b and cs plus d. So the first thing we always do is we multiply by the common denominator. So we get s squared plus 2 equals to as plus b times s plus 1 squared plus 1 plus cs plus d, plus cs plus d times s squared plus 1. So we're still gonna plug in roots, but in this case the roots are gonna be complex numbers, but that's fine. So first we plug in the easier root, which is s equal to I. This comes from the factor s squared plus 1 equal to 0. So if we plug in s equal to I, then we get I squared plus 2 equals to ai plus b times I plus 1 squared plus 1. The second term vanishes. And I squared plus 2 is 1. And it's equal to ai plus b times, let's expand this. So this is I squared plus 2i plus 1 plus 1. I squared is negative 1. So that's 2i plus 1. If we FOIL it, this is equal to negative 2a and plus ai plus 2bi plus b. If we separate the real and the complex part, we get negative 2a plus b, this is the real part, plus a plus 2b, complex part, imaginary part, times I. So we get negative 2a plus b, the real part, is equal to the real part on the left, is 1, and a plus 2b is equal to complex, imaginary part is 0. Alright, and then here we can use the Cramer's rule. So A is equal to the determinant of the coefficients in the denominator and replacing the first column by the constant part. So it's 1, 0, 1, 2. This is equal to 2 over -4 minus 1, so it's 5. So it's -2/5. And b is equal to, the denominator is the same thing. The numerator, you replace the second column by the constant term. So this is equal to -1, which is positive 1/5. Okay, so that's for A and B. And we're going to do the same thing for C and D. So let's shift the board down so we can keep doing this. Let's keep the partial fractions. Okay, so for C and D, we have to solve s plus 1 squared plus 1 equal to 0, and we get s plus 1 squared is -1, so s plus 1 is I, so s is -1 plus I. So we can plug in s equal to -1 plus I. So the left-hand side is -1 plus I squared plus 2. Right-hand side, the first term vanishes, and the second term is c times -1 plus I plus d. The whole thing times -1 plus I squared plus 1. So a lot of algebras involved here. -1 plus I squared is 1 minus 2I plus I squared. And this part is the same. 1 minus 2I plus I squared plus 1. And this, the left-hand side is equal to 1 and negative I, 1 I squared canceled. So this is -2I plus 2. And then this we can simplify a little bit. This is -c plus d plus ci. And this is equal to -2I plus 1. And the right-hand side, we have to FOIL it out. So we get -2, -c plus d times I plus -c plus d minus 2c times I squared and plus c times I. And then if we combine the real and complex part, then we get the real part is going to be, so this is -1, so this is plus 2c, so the real part is c plus d. And the imaginary part is, this is 2c minus 2d here, and then we're adding a c here, so it's 3c minus 2d times I. So compare the real part and the imaginary part, we get c plus d is equal to the real part, which is 2. Real part equal to the real part. And the imaginary part equals to the imaginary part. So we get 3c minus 2d is equal to -2. And same thing with Cramer's rule, c is equal to this determinant in the denominator and this determinant in the numerator. -2, -4 plus 2, -2 minus 3, so it's 2/5. And then d is similar. So 2, -2, 1, -2, 1, 1, 3, -2. The denominator is the same. The numerator is -4 plus 2. Oh, I replaced the wrong column here. Pardon me. So d is equal to, you keep the first column and then replace the second column. So it's -2 minus 3, and this is -2 minus 6, so it's -8. So it's 8/5. Okay, so now we have the values for A, B, C, and D. Let's copy it down. We're not done yet. So our capital Y is equal to A is negative 1, 2/5, I think, yeah. So it's negative 2/5 s plus B is 1/5. This is over s squared plus 1 plus C is 2/5. B is 8/5. And then this is over s plus 1 squared plus 1. Okay, let's move it over. Okay. So we want to look at a chart. So we need for the cosine and sine, we need the terms 1 over s squared plus 1. Technically, we need a s over s squared plus 1 and 1 over s squared plus 1 and s plus 1 over s plus 1 squared plus 1 and s plus 1, not just 1. 1 over s plus 1 squared plus 1. So we need to find these coefficients. For the first two, it's not too bad. They're just a and b. So this is negative 2/5 and this is 1/5. For the third one, because this is the only term with s on top, so this is 2/5 and 2/5 times s plus 1 is 2/5 s plus 2/5. And so the remaining of 2/5 from 8/5 is 6/5. Okay. So that's almost it. So that's capital Y, and then our solution, little y, is the inverse Laplace transform of uppercase Y. So this is equal to the coefficient stays. And the first two terms have no shifting, so it's just cosine t and sine t. And the third and fourth terms have shifting with a equal to negative 1. So it's e to the negative t times cosine t and e to the negative t times sine t. All right, so that's it for section 10.3.